Okay, everybody, this is your lesson on the counting principle. And let's go ahead and just get started here. Talk about what the counting principle is all about. Counting principle is a very quick way to count the number of possible combinations of a given amount by multiplying the number of possible ways two or more events can occur. So you're looking for possibilities. This is a great way to help us figure out if, how many combinations of coin flips, or how many combinations of coin flips and spinners spins, or how many combinations of a coin flip and a roll of the die. So there's two different strategies that you can take when finding or when using the counting principle. One is using tree diagrams, and another one is just using multiplication, which is actually just the counting principle. Let's go ahead and get right into our first example. Example A, I'm going to show you how to use a tree diagram, which can be kind of confusing, but let me just kind of talk you through it. This doesn't always work out best for everything. So tree diagrams are good for explaining and showing you how things work, but they're not always best suited for every kind of counting principle problem. So here's your example. When picking out your outfit today, you noticed you had two types of pants. You had cargo and jeans, three types of shirts, a pink, a black, and yellow shirt, and three kinds of shoes to wear. You have tennis shoes, high tops, and sandals. And the question is, how many outfit combinations are there? So I'm going to show you how to do this using a tree diagram. So what you do is you start with any of the three types of, any of the three types of your outfit, your pants or your shirt or your shoes. I'm going to start with the pants. And there's two different possible pant combinations, cargo or jeans. Okay, so this is where our tree is going to start. So it's going to branch off from here. It's going to go off into, this direction. You're going to branch everything off. So let's branch it off into the combinations of shirts. Now, how many shirts are there? There's three kinds of shirts. So we're going to draw three branches coming out of cargo. And what are the types of shirts? There's a pink, there's a black, and there's a yellow shirt. And the same can be said about jeans. If you're wearing jeans, well, you're going to have also three kinds of shirts to pick from as well. Cargo, just because you picked cargo pants doesn't mean you have to wear these three. You could wear jeans or these three. So jeans will branch off into three shirts as well, and they will be exactly the same shirt. Pink, black, and yellow. So here's your combination so far. So far you can wear cargo pants with a pink shirt, you can wear cargo pants with a black shirt, or you can wear cargo pants with a yellow shirt. Same can be said about jeans. Jeans pink, jeans black, or jeans yellow. And we're not even done yet. So let's go ahead and get into our last possible outfit combination, which is the kind of shoes you're going to wear. And since there's three kinds of shoes, you're going to branch it off into three different branches. And just like we did with shirts, we're going to list the types of shoes: tennis shoes, high tops, and sandals. And we'll just do the same thing with black: tennis, high tops, and sandals. Tennis shoes, high tops, and sandals. Tennis shoes, high tops, sandals. I'm sounding like a broken record here, but that's how that goes. And you can see right now why tree diagrams can get kind of nutty. I mean, they get pretty big. And when I was making up this lesson, I really had to squeeze all this in here. It gets really hard to draw, and I used a computer to create all this. It gets hard to draw all these in. It can get kind of messy, especially if you're dealing with an increasingly higher number of combinations. You don't want to have too many. So you can see why this way isn't always suited for everything. But there you go. Here's all your combinations. So, from here, the arrow that's coming out of there, that means you wore cargo pants, a pink shirt, and tennis shoes. That's one combination. Or if I circle this one right here, that's a terrible circle, but I'm sorry, using a mouse. You can wear cargo pants, black shirt, sandals. So you just follow the arrow. Cargo pants, black shirt, sandals. See how that works? Right here, high tops. If I follow the arrows from jeans, you wore jeans, a black shirt, and high tops. Oh my goodness, sorry about that bad line. Sorry, this mouse is not the best to draw with. All right, so that's a tree diagram. And then if you look at this part of your tree diagram, this is all your combinations. That's how many combinations you have. So what does that come out to? 3, 6, 9, 12, 15, and 18 total. So you have 18 combinations. Now I know you're thinking like, oh, I could have done that much easier way just by multiplying. And that's what I'm going to talk about next. But I do expect you, we expect you to be able to show a tree diagram as well. Okay, here's the second method, which is using multiplication. This is actually just the counting principle, you know. So here's the question. Maddie's at the kennel. She's picking out a new puppy because she's getting a reward. The choices are in 4 categories. So she's got a lot of choices to make. We're going to put them into groups. Group A, B, C, and D. So in Group A, she has 4 different kinds of dogs. Spaniels, Hounds, Terriers, and we all love mutts. Group B, well, there's only 2 combinations of the sex, so it's either going to be male or female. And then Group C, she's going to have her choice of the color. What color does she want it to be? So I don't know if you'd really have these kind of color combinations, but you know, with today's science and what we can do with cloning, you know, anything's possible. But she has brown, white, black, red or golden, you know, like a golden retriever, or multicolored, bunch of colors. And then Group D, you have the kind of hair, short hair, long hair, or no hair. So there's all your groups. You have 4 groups, and then you're going to look at how many possibilities do you have from each group. So Group A has 4 choices. Right there, 4 choices. Group B has 2 choices. Group C has 5, and Group C has 3. So with counting principle, all you have to do is multiply the number of choices from each group. So there's 4 from Group A times 2 choices from Group B times 5 choices from Group C times 3 choices from Group D. So, you know, you could use your calculator on these, especially if the numbers get really huge. But 4 times 2 times 5 times 3 comes out to 120 dog combinations. So Maddie has her choice, theoretically. You know, this is probably not real, but she has a choice of 120 dogs, or you know, that number of combinations, 120 dog combinations if they were to clone them, I guess. All right, so that's a really super simple way of doing it. I definitely agree that this is the preferred method. This is the way I'd want to do it. I wouldn't want to make a tree diagram of this, especially when you get to the end of it. When you get to the end, you're going to end up having 120 branches eventually. That's a lot of branches, and it can get definitely confusing. So I agree with you. So here's your practice problems. Try these out for good luck. Example 1 is to draw a tree diagram for a dice roll, a coin flip, and then another coin flip. In your second example, your second practice problem, is to use the fundamental counting principle, which is multiplication basically, to find the number of combinations of picking the following. So let's say, like, I don't know, these numbers or these items are in a bag or something, or you know, you have these choices. You have a letter in the alphabet, a prime number between 1 and 20, and one of the states in our country, a state in America. So I can go ahead and pause you, or I can't pause it. You can go ahead and pause the video at this moment and try these out on your own. Try drawing a tree diagram for the first one. It's not going to be that bad. You're not going to have thousands of branches. Try out number 2. Just use your multiplication and see what you get. So pause this video and then hit play when you're ready to check. All right, you just hit play. Here's how you do practice problem number 1. So you have a die, okay? So here's all the faces of the die, 1, 2, 3, 4, 5, or 6. You have 6 possibilities for the die. And then the first coin, well, when you flip a coin, you only have 2 possibilities. You have either heads or tails. So you flip it and you have heads or tails. You can get a 2 or heads or tails. You can get a 3 or heads and tails. You can get a 4 heads or tails. 5 heads or 5 tails, or 6 heads or tails. That's how that goes. All right, so there's your coin flip. So right there, you can tell you have 12 possible combinations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so you have 12 possibilities. 6 times 2 is 12, and that seems to all work out. If it doesn't work out, use your basic counting principle, just multiply and see if everything makes sense. Okay, now we flipped a coin again. So let's look at those combinations. Well, every coin that we flip first is going to branch off into 2 more coins, or 2 more possibilities, I should say, heads or tails. And so everything branches off, and this is what I was talking about. They get crazy, especially if you deal with more and more numbers. They get hard to draw out. So every coin, if you look at every die roll, coin, flip combination, you have 24 possible combinations. And you can verify that with just the basic counting principle. 6 times 2 is 12, and 12 times 2 is 24. And that's verifiable. 24 combinations. So, if somebody asks you, hey, what's the chances of flipping or rolling a 4, getting a heads, and getting another heads, so 4 heads, well, the chances of that happening will be 1 in 24. In that order, I should say. You have a 1 in 24 chance of that happening. 4 heads and a heads. Your chances of that happening is 1 in 24. Okay, let's go on to the next one. Your next example here is you have a letter in the alphabet, a prime number between 1 and 20, and a state in the USA. Group A is pretty simple. Well, there's only 26 letters to pick from in the alphabet. Group B, you have to do a little bit of thinking here. Sorry to make you think, but let's look at all the prime numbers between 1 and 20. So 2 is a prime number, 3 is a prime number, 5 and 7. The next one is 11, 13, 17, and 19. Hopefully none of you picked 9 or 4. A lot of you think that 9 is a prime number. It is not a prime number. So how many prime numbers are there? Yes, there are 8. And how many states? There are 50 states. Hopefully you all knew that. And this is just a matter of multiplying. Okay, so just do 26 times the number in group B, which is 8, times 50. Okay, now this, if you were to make a tree diagram of this would be insane. It would be huge. You'd need a big piece of butcher paper to figure out all the combinations. So not realistic for a tree diagram. More realistic for using the counting principle, which is just straight up multiplication. And there you have it. 10,400 combinations of picking a letter, a prime between 1 and 20, and a state in our country. And there it is. There's your lesson on counting principle. Everyone have a good night. See you tomorrow. Make sure you guys fill out your flip notes and bring any questions to class if you have them. Good night.